Ever stop and think about how your banking app, your social media feed, or pretty much any big online service just works? How does it all hold together without collapsing into total chaos? Well, the secret isn't some kind of magic. It's a blueprint. And today, we're going to pull back the curtain on that blueprint. Data modeling. It's the invisible architecture that holds up almost every single reliable app you use every day. I mean, really think about it. We're talking about banks, online stores, your favorite apps. They're all juggling these massive mountains of information. So, how do you organize millions, even billions of facts about customers and products and all their transactions without it turning into an absolute mess? This right here, this is the core challenge that data modeling was born to solve. To really get why today's solution is so brilliant, we first have to take a look back at the problem. Before we had modern databases, managing data was, well, it was a total mess. Just imagine a bank where every department, savings, loans, you name it, kept its own separate records with its own separate apps to manage them. And this really shows you the leap from chaos to order. In that old file-based world, if a customer changed their address, you might have to hunt down and update it in like a dozen different files. If you miss just one, boom, you've created a conflict. That's what we call data redundancy, and it leads straight to data inconsistency. The system literally can't trust its own information anymore. The database approach, though, it changed the whole game by creating one single shared source of truth for everyone. So, how did we make that jump? How did we get from that tangled mess to a world of order? Well, we did what any good builder would do. You create a blueprint before you start building. And in the world of data, that blueprint is called a data model. It's the master plan that makes sure everything is going to fit together just right. Now, the key thing to get here is that data modeling isn't about the specific software you're going to use or what brand of hard drive it sits on. Nope. It's a high-level, abstract design phase. It's where you take a big step back and just answer three basic questions. What information do we actually need? How does all that information relate to each other? And what are the rules it all has to follow? And honestly, it's that simple. I mean, you would never, ever build a house without architectural drawings, right? Of course not. You'd end up with staircases to nowhere or plumbing that doesn't connect. It'd be a disaster. A data model does the exact same thing for information. It's the official plan that prevents that kind of digital disaster. Okay, so just like an architect's blueprint uses standard symbols for things like doors, windows, and walls, a data model is put together using a few simple but really powerful building blocks. And there are only three main ones you need to know about. First up, we have the entity. Just think of this as the main noun in your data story. It's the core person, place, thing, or concept you want to keep track of. So for a company, your big entities would be things like employee, department, and project. Each one of these gets its own container, its own table. So if the entity is our noun, then we need attributes to be our adjectives. These are just the properties, the details that describe our entity. What do we need to know about it? So for our employee entity, the attributes would be stuff like their name, their ID number, their address, and their salary. These become the columns inside our employee table. Simple as that. And the final piece of the puzzle is the relationship. This is the verb that connects all our nouns. It's what brings the whole model to life. An employee doesn't just exist in a bubble, right? They work in a department. They are assigned to a project. These relationships, these are the lines that connect the dots, the glue that hold the entire system together. So, for example, a simple line drawn between the employee box and the project box can represent that relationship works on. And just like that, with one little line, we can see exactly how these two separate ideas are connected. That's the power of this, making those connections clear and visible to everyone. Now, a full-on data blueprint isn't just a single drawing. It's actually more like a series of models that take us all the way from a high-level, back-of-the-napkin sketch to a detailed physical plan. And it gets more and more specific with each step. So it all starts with the external model. That's what a specific user sees. Think of an HR manager. They only need to see employee data, not sales figures. Then you zoom out to the conceptual model. This is our main blueprint, the one that shows how everything connects across the entire organization. From there, we get technical with the internal model, which is like the contractor's plan. It adapts the blueprint for a specific system, say Oracle or SQL Server. And finally, you have the physical model, which gets down to the real nitty-gritty of how the ones and zeros are literally stored on a disk. So why do we go through all this trouble? Why all these layers and models? Because a good blueprint, a really solid data model, is what stops those messy problems we talked about at the beginning. It prevents the chaos before it even has a chance to start. See, without a proper model, databases get these nasty glitches we call anomalies. They're painful and they're dangerous. For example, an insertion anomaly could mean you literally can't add a new project to the system until you assign an employee to it. An update anomaly? That's when you change a project's budget in one place, but it stays wrong in 10 other places. And then there's the scariest one, a deletion anomaly. That's when the last employee on a project leaves the company, and deleting their record accidentally wipes out the entire project record along with them. Yikes. And this is where that blueprint really proves its worth. A good model just solves these problems. That issue where you can't add a project? Not a problem, because projects and employees live in their own separate, independent tables. That nightmare of updating a budget in 20 different places? Solved by what we call controlling redundancy. The budget now lives in exactly one spot. You change it once, and it's correct everywhere. And that risk of accidentally deleting a whole project? Gone. By enforcing data integrity, the system's rules protect that critical information. The blueprint keeps everything safe and sound. So the next time you're booking a flight or updating your profile or buying something online, just take a second. Think about that elegant, invisible structure that's working underneath it all. What hidden blueprints, what carefully designed data models are chugging away behind the scenes to make it all just work? Thanks for joining us on The Explainer.